In question 1, we are told that a, b, and c are integers greater than 0, such that c is 3a plus 1 and a plus b plus c is 15. And we need to prove by exhaustion that the product ABC is always a multiple of 4. And we've been given this table to help us illustrate our answer. So let's start with the first possible value for a. So since we are told that all of the a, b, and c are positive integers, then I will consider a being 1. Knowing that c is 3a plus 1 makes c 4, and given the fact that the sum of the three integers is 15, this means that b is 10. So the product of a, b, c is 1 times 10 times 4, which is 40, which is 10 times 4. It's a multiple of 4, so this is correct. The next possible value is 2 for a, which makes c 6 and makes b 7. And if I do 2 times 7 times 6, I get 84, which is again a multiple of 4. It's 21 times 4, so that's also correct. And then if a is 3, this makes c 2 and b 10. And 3 times 10 times 2 is 60, which is 15 times 4. So again, that's a multiple of 4. And then if I consider a to be 4, this makes c to be 13, which makes b to be negative 2, which violates the fact that the three integers should be greater than 0. So I need to cross this out to show that this is not a valid solution. And therefore, the only thing missing is for me to write a full conclusion. So we conclude that if a, b, c are integers greater than 0, satisfying the two conditions, that c is 3a plus 1 and a plus b plus c is 15, then a, b, c is always a multiple of 4. In question 2, we've got a sequence defined here recursively with u1 being 3 and the next term being 2 minus 4 over the previous term, and we need to determine the values of u2, u3, and u4. Well, using the recurrence formula here, u2 will be 2 minus 4 over u1, which is going to be 2 minus 4 over 3, which gives an answer of 2 over 3. Moving on to u3, this is going to be 2 minus 4 over u2, which is 2 minus 4 over the 2 over 3, and this gives an answer of negative 4. And u4 is going to be 2 minus 4 over u3, which is going to be 2 minus 4 over negative 4, which is equal to 3. I could also do this automatically on the calculator. So I go on my calculator, I store 3 on my answer key, this is the first term, and then I do 2 minus 4 over the ans. So each time I press the equal sign, I generate the next term. So if I press it once, I get the 2 over 3, which was here, the second term. I press it again, I get the negative 4, and then I press it again, I get the 3. Moving on to part B, we need to evaluate this sum. So we're looking at the sum of UR from R equals 1 up to 100. So this is pretty much U1 plus U2 plus U3 plus dot 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 up to U99 and then U100. We have observed from part A that the sequence goes 3, 2 over 3, negative 4, and then again 3, 2 over 3, negative 4, dot dot dot. So we are looking at a periodic sequence of order 3, so every 3 terms it repeats itself. So if I consider the sum here, we've got here 33 periods. So 33 times 3 is the 99 terms. So I can easily consider that each period contributes a minus 1 over 3 to the sum, because if I do 3 plus 2 over 3 plus negative 4, I get minus 1 over 3. And then U100, it's going to be the first term of a new period. So this is going to be simply the number 3, because the first term of the period is 3. So the summation of UR from R equals 1 up to 100, it's going to be 33 times the minus 1 over 3 plus 3, which gives an answer of negative 8. In question 3, we are taught to show all stages of the working with solutions relying on calculator technology not being acceptable, and we need to solve the given trigonometric equation for theta being in degrees between 0 and 360. So starting off with the equation given, we've got 2 tan theta plus 3 sine theta is 0. So the first thing to do is write tan theta as sine theta over cos theta. So I have 2 sine theta over cos theta plus 3 sine theta is equal to 0. I will be multiplying throughout by cos theta to get 2 sine theta plus 3 sine theta cos theta is equal to 0, and I will factor out the sine theta, so sine theta brackets 2 plus 3 cos theta is equal to 0, which means that either sine theta is 0 or 2 plus 3 cos theta is equal to 0. So we've got 3 cos theta here is negative 2, leading to cos of theta being minus 2 over 3. And I will proceed in finding the principal values. For sine theta being 0, the PV, the principal value, is 0. So I get theta is the PV of 0 plus 360k, or theta is 180 minus 0 plus 360k. Whereas for cos theta being minus 2 over 3, I'm going to go on my calculator. The PV is shift cos of minus 2 over 3, which gives an answer of 131.810 dot dot dot. So let me show you this on the calculator. I will do shift the cos of minus 2 over 3. So this is the principal value. I will store it on A. So once I've stored it on A, I can proceed for theta being plus minus the PV, which is A, plus 360k. So if I press menu on my calculator and then 9, I will say that f of x is A plus 360x, whereas g of x is going to be minus A plus 360x. And I will start at negative 2, say go up to 2. The important thing is the step to be 1, and this will substitute different values for k. So each k will generate a different value for theta, and I will only be choosing those values that are in between the range of 0 to 360. So I can see here that the only solutions within the range are 131.8 and 228.2. So from the sine theta being 0, I can see that the only solutions are the 180 and the 360. The 0 is not included. It's a strict inequality on the left end, whereas from theta is plus minus A plus 360k, I got the 131.8 and the 228.2. And then in part B, we need to hence or otherwise find the smallest positive solution of 2 tan of 2x plus 40 plus 3 sine of 2x plus 40 being 0. So if I compare for a moment with the original equation, we can see that the theta became the 2x plus 40. So let me write this down. We've got theta is equal to 2x plus 40, and this means I will be equating the 2x plus 40 with the 131.8, which is the smallest positive solution we obtained in part A. So 2x plus 40 is equal to 131.8 dot dot dot. I'm using full accuracy here. So 2x is equal to 91.8 dot dot dot. And if I divide by 2, I get that x is 45.9 degrees. In question 4, we've got f of x here, a cubic in x with unknown constants a and b, and we are told that 2x plus 1 is a factor of f of x, and we need to show that this leads to a plus 4b is negative 56. Let's start with the factor theorem. If 2x plus 1 is a factor, this means that f of minus a half is 0. So let me substitute x being minus a half. So this leads to 0 is equal to 4 times minus a half cubed plus a times minus a half squared minus 29 times minus a half plus b, leading to 0 is equal to minus a half plus a over 4 plus 29 over 2 plus b. Now this leads to 0 is equal to 14 plus a over 4 plus b. I will multiply throughout by 4 to get 0 is 56 plus a plus 4b. And therefore we've got negative 56 is a plus 4b as required. In part B, we are told additionally that when f of x is divided by x minus 2, the remainder is negative 25, and we need to find the second simplified equation linking a and b. So using the remainder theorem, we know that when we divide by x minus 2, the remainder is given by f of 2. So f of 2 is negative 25, which means that we've got 4 times 2 cubed plus a times 2 squared minus 29 times 2 plus b is equal to 25, leading to 32 plus 4a minus 58 plus b is equal to 25, and therefore we've got that 4a plus b is equal to 1. In part C, we need to use algebra to determine the value of a and the value of b and then fully factorize f of x. Well, we have established that a plus 4b is negative 56 and 4a plus b is 1. So from the second equation, I can leave b on its own. So b is 1 minus 4a and solve the simultaneous equations by substitution. So I've got a plus 4 times 1 minus 4a is equal to negative 56, leading to a plus 4 minus 16a is negative 56. So minus 15a is minus 60, which means that a is 4, and b is 1 minus 4 times 4, which gives an answer of negative 15. In II, we need to fully factorize f of x. So now that we have established the values for a and b, let's write down the full expression for f of x. It's 4x cubed plus 4x squared minus 29x minus 15. Well, we already know that 2x plus 1 is a factor, so I will proceed with the long division. So I'm multiplying 2x to get 4x cubed, so I need to multiply it by 2x squared. So I've got 4x cubed plus 2x squared, and I deduct. This leads to 2x squared minus 29x minus 15. I will multiply 2x by x to get 2x squared plus x, and I deduct again, leading to minus 30x minus 15. So it's going to be a minus 15 here, leading to minus 30x minus 15, and the remainder of 0 as expected. So at the moment, we have established that f of x is 2x plus 1 times 2x squared plus x minus 15. Well, we've been asked to fully factorize the expressions, so I will proceed in factorizing the given quadratic. So it's going to be 2x plus 1 times 2x minus 5, x plus 3. Please be careful not to proceed in solving f of x is 0. This is a common mistake. So we have only been asked to factorize f of x, so we need to stop here. That's going to be my final answer. In 5i, we need to solve 3 to the a70, giving the answer to 3 decimal places. So I will start by taking log of both sides. So log of 3 to the a is equal to log of 70. The a can come down, so a log 3 is equal to log of 70, which means that a is log of 70 divided by log of 3, which gives an answer of 3.867 for a. In II, we need to determine the exact value of b such that 4 plus 3 log b is log of 5b, all base 3. So the first thing to do is take the 3 up using the power law of logarithms, which leads to 4 plus log of b cubed base 3 is equal to log of 5b base 3. This means that log of b cubed base 3 minus log of 5b base 3 is equal to negative 4. Now we've got that log minus log is the log of the quotient. So we're looking at log of b cubed over 5b base 3 is equal to negative 4. So log of b squared over 5 base 3 is negative 4. Now I will open up the log by saying that b squared over 5 is equal to 3 to the negative 4. So 3 to the negative 4 is 1 over 81. So b squared over 5 is 1 over 81. And if I cross multiply, this takes me to b squared is equal to 5 over 81. And therefore b is the square root of 5 over the square root of 81, which is 9. Notice that b cannot be negative, so my only solution is b is root 5 over 9. In question 6, we're studying a river, and at a particular place, the river is 15 meters wide, so that's the 15 there on the x-axis. Now we need to use a trapezium rule with all the y values to estimate the cross-sectional area of the river. So we need to estimate this area here. So I will start by generating the table of values. We've got the x values here, and we can see that they've got a constant difference of 3. That's going to be the height of the trapezia, and these are the corresponding y values. Well, we know that the area is simply going to be given by using the trapezium rule here, which is a half times the height of the trapezia, which is 3. Then we've got the first and the last y values once, and all intermediate y values twice. So 2 times 1.52 plus 2.74 plus 3.12 plus 3.08. So if I plug this on the calculator, I get 31.38 square meters. In part B, we are told that the water is flowing at a constant speed of 1.5 meters per second, and we need to use the model and the answer to part A to estimate the volume of water flowing each minute. So let's start by considering what's happening here. We've got the cross-sectional area here being estimated to be 31.38 square meters. We know that we are flowing at 1.5 meters per second, which means that in a minute, I will do that times 60. So 60 times 1.5 is 90 meters. So we're essentially looking at a prism with a cross-sectional area of 31.38 and a length of 90. So the volume is going to be the cross-sectional area times the length. This gives an answer of 2,842.2 cubic meters, which correct to two significant figures is 2,800 cubic meters. And finally, in part C, assuming the model, we need to state, giving a reason for our answer, whether our answer is an overestimate or an underestimate. Well, this was the graph we originally had. Let me flip it around so that the y-axis goes positively upwards. If I draw my trapezia, I can see that all of the trapezia lie below the curve, so all of this area is missed, is not caught by the trapezium rule, and therefore I will simply say that since the curve bends outwards, the trapezia lies below the curve, and therefore the answer is an underestimate. Please be careful, you need to mention the word trapezia here to get the mark. In question 7, we've got the circle C centered at the point X, and we've got the straight line L having equation y is 5 over 2x minus 55 over 2. This line L is a tangent to the circle at the point N, and we need to determine the equation of the straight line passing through Xn. So if I quickly add the information on the diagram, this is the equation of the straight line L. We need to find the equation of the straight line passing through points X and N, and we know that the angle here should be a 90-degree angle because the tangent and the radius are at 90 degrees. So let's start by pointing out that the gradient of the straight line L is 5 over 2. This means that the gradient of the radius, the gradient of the straight line we're trying to find, its equation should be minus 2 over 5. So I'm flipping the gradient and changing the sign. And then using the fact that y minus y1 is mx minus x1, we can simply say that y minus negative 3 is equal to minus 2 over 5 brackets x minus 4. So we are looking at y plus 3 is equal to minus 2 over 5 times x minus 4. I will cross multiply with the 5 to get 5y plus 15 is equal to minus 2x plus 8. And I will be collecting everything on the left-hand side, leading to 5y plus 2x plus 7 is equal to 0 as required. In part B, we need to find the coordinates of N and then proceed in finding the equation for the circle. Now recall that N is the point of intersection between the line passing through the radius and the tangent. So we've got the equations of the two straight lines shown here, and I will be solving the simultaneous equations to determine x and y. So it's easy for me to substitute the y into the second equation here. So we're looking at 5 brackets 5 over 2 x minus 55 over 2, close brackets, plus 2x plus 7 is equal to 0. I can expand this to get 25x over 2 minus 275 over 2 plus 2x plus 7 is equal to 0. I'll be multiplying throughout by 2 to get rid of the denominators, get rid of the fractions. So we've got 25x minus 275 plus 4x plus 14 is equal to 0. And therefore we have 29x is equal to 261, which means that x is equal to 9. I will proceed in finding y. So y is 5 over 2 times 9 minus 55 over 2. This gives an answer of negative 5, and therefore we conclude that the point then has coordinates 9, negative 5. In II, I need to find an equation for C, and to do that I need to start by finding the radius. So we know that the distance between the points x1, y1 and x2, y2 is given by this formula here. We have already seen on the diagram that x has coordinates 4, negative 3. So the radius is simply the distance between x and n. So I will substitute in the given formula here. So it's the minus 3 minus the negative 5 squared plus the 4 minus 9 squared and all square root. So this gives an answer of root 29. This is the radius of the circle, and knowing that the circle centered at alpha beta with radius r has equation x minus alpha squared plus y minus beta squared is r squared, we can simply write down that x minus 4 squared plus y plus 3 squared is equal to root 29 squared, which is the equation of the circle C. In question 8, we've got a large theater with n rows of seats, and the number of seats in the first row is A, and each subsequent row has 4 more seats. So we go from A to A plus 4, then NA plus 8, and so on. So the number of seats are forming an arithmetic sequence, and we are told that the total number of seats in the first 10 rows is 360, and we need to determine the value of A. So we are certainly looking at an arithmetic sequence with a common difference of 4. And we know that the sum of the first n terms of an arithmetic sequence is given by n over 2, 2a plus n minus 1d. So we have just been told that S10 is 360. So I will substitute n with 10. So it's 10 over 2, 2a plus 10 minus 1 times d, which is 4. So we're looking at 360 is equal to 5 brackets 2a plus 36. Well, if I divide both sides of the equation by 5, I get 72 is equal to 2a plus 36, leading to 36 is 2a, and therefore a is 18. We're then told that the total number of seats in the n rows is 2,146, and we need to show that this leads to this quadratic equation. So we have just been told that Sn is 2146, which is equal to n over 2. Now 2a is 2 times 18 plus n minus 1 times d, which is 4. So we've got 2146 is equal to n over 2 times 36 plus 4n minus 4. So 2146 is n over 2 times 32 plus 4n. I will expand further to get 2146 is equal to 16n plus 2n squared. I will collect everything on the right hand side, leading to 0 is 2n squared plus 16n minus 2146. So if I divide throughout by 2, I get 0 is n squared plus 8n minus 1073 as required. In part C, we need to state the number of rows of seats in the theater and then find the maximum number of seats in any one row. So we have this quadratic equation in n and I need to solve it. I can use my calculator. So I press menu, it's option A. It's a polynomial of degree 2. So my A is 1, my B is 8, and my C is minus 1073. So this will give me the answer straight away. So the first solution is n is equal to 29, and the second solution is minus 37. So or n is minus 37, which is of course rejected. It's not valid because it's a negative value. We know that n should be a positive integer. So we've got the answer for the number of rows of seats in the theater, which means I can proceed in finding the maximum number of seats in a row, so that's going to be the number of seats in the last row. Well, we know that un is a plus n minus 1d, and I simply need to find the number of seats in the 29th row, so it's going to be 18 plus 29 minus 1 times 4, which gives an answer of 130 seats for the maximum number of seats in any one row. In question 9, we've got a sketch of part of the curve with this equation here, and we need to use calculus. This means differentiation to find the range of values of x for which y is increasing. This means that we're looking at dy dx being greater than or equal to 0. So the first thing to do is write the expression for y in index form. So y is 2 over 3 x squared minus 9x to the half plus 13, which means that dy dx, remember that when we differentiate, we multiply by the power and we deduct 1 from the power. This will give me 4x over 3 minus 9 times a half x to the minus a half, which simplifies to 4x over 3 minus 9 over 2x to the half, and we need this to be greater than or equal to 0. So we've got 4x over 3 is greater than or equal to 9 over 2x to the half. Well, I will cross multiply to get 8x to the 3 over 2 is greater than or equal to 27, leading to x to the 3 over 2 greater than or equal to 27 over 8, and therefore x is greater than or equal to 27 over 8 raised to the power of 2 over 3, which simplifies to x being greater than or equal to 9 over 4. Please notice here that if you use a strict inequality, that would also be okay for this part of the question. We are then given that the point P lies on C with coordinates 9, 40 as shown here. The line L is a tangent to C at the point P, and we need to use calculus to determine the exact value of the shaded area R. So the first thing to do for me is to drop the perpendicular from P onto the x-axis, and we know that this distance here is the y-coordinate of point P, which is 40. So the idea is for me to use integration to find all of this area and then deduct the area of the triangle here. So it's an 8-mark question here, so there's a lot of work involved, and I will first start by trying to get the equation of the tangent here, because I will need the cut on the x-axis for me to proceed in finding the area of this triangle here. So let me start by evaluating dy dx at x is 9. We've got the expression for dy dx from part A. So that's going to be 4 times 9 over 3 minus 9 over 2 root 9, which gives an answer of 21 over 2. So we've got the gradient, we've got the point, it's the point P9, 40. So y minus 40 is equal to 21 over 2 brackets x minus 9. And we know that I will call this point here Q. So at point Q, y is 0. It's a cut on the x-axis. So let me write this down. At Q, y is 0, leading to minus 40 is 21 over 2 brackets x minus 9. Well, I will cross multiply to get minus 80 is 21x minus 189, leading to 109 is 21x. So the x coordinate of point Q is 109 over 21. So I will write this down here. So 109 over 21. So the shaded area R will be the integral from 0 up to 9 of 2 over 3 x squared minus 9x to the half plus 13 dx. So this will give me all of this area here, and then I need to deduct the area of the triangle, which obviously has a base of 9 minus the 109 over 21 and a height of 40. So minus base 9 minus 109 over 21 times the height of 40 over 2. Well, in integration, we're increasing the power by 1, dividing by the new power. So this will give me 2 over 3 x cubed over 3 minus 9x to the 3 over 2 over 3 over 2 plus 13x, and we've got limits of 0 and 9, minus the area of the triangle, which works out to be 1600 over 21. So I will simplify the result of the integration. So we've got 2x cubed over 9 minus 6x to the 3 over 2 plus 13x from 0 up to 9 minus 1600 over 21, and I will now substitute the upper limit and then the lower limit. So we're looking at 2 times 9 to the power of 3 over 9 minus 6, 9 to the 3 over 2 plus 13 times 9. And it's obvious that if I substitute the lower limit of 0, everything will be 0. So minus 0 minus the area of the triangle, which was 1600 over 21, which leads to an answer of 857 over 21 units squared for the shaded area R. In question 10, we are asked to find in ascending powers of x the second, third, and fifth terms of the binomial expansion of 3 plus 2x raised to the power of 6. So I could go ahead and find the first 5 terms of this expansion. So we're looking at 3 plus 2x raised to the power of 6. So we start with the full power loaded on 3, so it's 3 to the power of 6, plus 6, choose 1, 3 to the power of 5, times 2x, plus 6, choose 2, 3 to the power of 4, times 2x to the power of 2. So each time I decrease the power in the first term by 1, and I increase the power of the second term by 1, and always the sum of the two powers is the total power of 6. So the next term will be 6, choose 3, 3 to the power of 3, 2x to the power of 3, plus 6, choose 4, 3 to the power of 2, 2x to the power of 4, plus dot, dot, dot. Well, the second term is obviously the term in x, the third term is the term in x squared, and the fifth term is the term in x to the power of 4. So we can see that the second term will simplify to 2916x, the third term is going to be 4860x squared, and the fifth term is going to be 2160x to the power of 4. Now for a particular value of x, these three terms form consecutive terms in a geometric series, and we need to find this value of x. Well, we know that in a geometric series, the ratio of consecutive terms is always the same. So I could say that u2 over u1 is u3 over u2. So I will be using these three terms here, treating them as u1, u2, and u3, which leads to 4860x squared over 2916x being equal to 2160x to the power of 4 over 4860x squared. So this simplifies to 5x over 3 is equal to 4x squared over 9, which means that 45x, if I cross multiply, is 12x squared. And if I divide throughout by x, I get 45 is 12x, which means that 45 over 12 is equal to x, which simplifies to 15 over 4 for x. In II, we're told that in a different geometric series, the first term is sine squared, the common ratio is 2 cos theta, and the sum to infinity is 8 over 5, and we need to show that this leads to the given quadratic in cos. Well, let's recall that the sum to infinity is given by a over 1 minus r, where a is the first term and r is the common ratio. So we're looking at 8 over 5, the sum to infinity given by the question, is equal to a, which is sine squared theta, over the 1 minus the common ratio, so 1 minus 2 cos theta. So I could cross multiply to get 8 brackets 1 minus 2 cos theta is equal to 5 sine squared theta. Well, we know that sine squared plus cos squared theta is 1. So this leads to expanding the left-hand side to give me 8 minus 16 cos theta. And on the right-hand side, I've got 5 brackets 1 minus cos squared theta. So 8 minus 16 cos theta is equal to 5 minus 5 cos squared theta. I will be collecting everything on the left-hand side to get 5 cos squared theta minus 16 cos theta plus 3 is equal to 0 as required. In part B, it says hence find the exact value of the second term of the series. So obviously I need to start by solving the given quadratic. So this factorizes into 5 cos theta minus 1 times cos theta minus 3 is equal to 0. So either 5 cos theta minus 1 is equal to 0 or cos theta minus 3 is equal to 0. So we're looking at 5 cos theta is 1. So cos theta is 1 over 5, or cos theta is equal to 3. Obviously this is rejected, it's not valid. Recall that cos theta attains values between minus 1 and 1. So we have established that cos theta is a fifth. I will find a. So a was given to be sine squared theta, which we know is 1 minus cos squared theta, which is 1 minus a fifth squared, which gives 24 over 25. And then we've got that the common ratio r is 2 cos theta, which is 2 times the a fifth, which is 2 over 5. And bearing in mind that the nth term of a geometric sequence is given by a r to the n minus 1, we can simply say that u to the second term would be a r, which is going to be 24 over 25 times 2 over 5, which gives an answer of 48 over 125.